Hello everyone, welcome to my channel. In this video of the Python tutorial, we are going to plot some graphics. First, we are going to install the necessary libraries, Matplotlib and Numpy. Once you install Matplotlib with this command, Numpy will also be automatically installed, so no need to install it individually. Once the libraries are installed, we can start writing our code. I've already installed the libraries, but I would like you to see which libraries the Matplotlib installation includes. So let's see it. You can see that there are several libraries: Matplotlib, QSolver, Cycler, Python Datautil, PyParsing, Numpy, as I've already mentioned, Pillow, and 6. In this video, we are going to be giving two examples. First one is rather simple. We are going to be plotting the sine function in a time interval. First, we need to import our libraries that we've installed. So let's write import NumPy. We are going to use this as in order to make a shortcut for NumPy. Let's say NP, for example. This is the most commonly used abbreviation, let's say, and we are going to import Matplotlib. However, not all of it. We are going to be having one of its interfaces, plot, and we are going to name it as PLT as short. Okay, now let's define our x-axis, which is going to be time in our example. For example, let's say t is equal to np dot. We are going to use the function linspace in order to create a linear space between a start point and an end point, and we are going to specify those in the parentheses. We are going to write, for example, 0, 2 as the linspace start and stop. Okay, now let's write our function, which is going to be rather straightforward. Let's say y is equal to np.sine. We are going to call the sine function from np, and we are going to write down 2 times pi, but we are going to write np.pi times t, and that's it. Okay, now we've defined our function. Let's do the plotting now. We are going to say plt.plot, and it's very simple. We are going to say t plus y. This is going to do the plot. However, we will not be able to see it until we write plt.show. We've saved our code. Let's try to run it. Let's see our file in the directory. Okay, we have the matplotlib x1.py. Let's run it. Python Okay, you can see that we have our plot here, t starting from 0, ending at 2, and we have our peak amplitudes as 1 and -1. Let's try to change the time interval. Let's, for example, say starting from -1, ending at 1, and let's save it. Let's run it again. Okay, you can see that it started from -1, ended at 1. For example, we can also change the amplitude of it. Let's write y is equal to 2 times our sine function. Let's save it and let's run it again. You can see that the amplitude has also changed. The peak values are 2 and -2. Okay, now we can go to our second example. In the second example, we are going to be using an extensive data set that we are going to be importing from a text file. I'm going to be using the text file that you can see on the right hand side. This text file includes the average sunspot numbers that are recorded each year starting from 1700 ending at 2020. Don't get confused with this .5 demonstration. It is used to indicate the middle of the year. So the second column is giving us the average sunspot numbers. This is obtained by getting the average of the daily numbers throughout a year. Third column will be giving us the standard deviation. However, if you see a -1 in anywhere in the file, you can see that there is no data available for this. And the fourth column gives us the number of observation points. Actually, we will be dealing with only the first and the second rows. So we are going to be plotting the year and the average sunspot numbers in that year, starting from 1700, ending at 2020. But as we look at this file, we can see that we have this asterisk that can cause us a problem. So I'm going to delete that one, and I'm going to save the file. Now we can start writing our code. First, let's again import our libraries. Import numpy as mp short. Import matplotlib pyplot as plt. Now we are going to be reading the text file. You can recall from our previous video how to read files. So I'm going to go to that file and I'm going to use this portion of it. I'm going to copy this one. I'm going to paste it right here. It's going to ask the user to input the file name. It's going to open it in read-only, and it's going to send the content to test2.file. Now that we have opened the file, we can use NumPy in order to create a matrix out of it. So let's see how it's done. For example, I'm going to say as matrix underscore data is equal to np dot. I'm going to call a method from NumPy, which is generate from txt, and I'm going to give the test2 file as the parameter. This method is going to create a multi-dimensional array for us. First, let's try to see the content of it by printing. Let's say print matrix data. Okay, let's run our code till this point. Let's say Python, I'm going to use example2.py. We are going to give the name of our text file. Okay. You can see that we have 4 columns and we have several rows. However, we are not able to print all of them. We need to do a modification on the code for this. We are going to import sys library, and we are going to say np.set print options max size. So hopefully we will be able to see the whole matrix. We save the file. Let's run it again. We have an obvious typo here. Let's save it. Let's run it again. Let's give the file name. Okay, now we can see the whole matrix starting from 1700 and ending at 2020. Now we can add the code to do the plotting. So first let's transfer our time series to different variables. So let's say x is equal to matrix data, and we are going to choose the first column, and we are going to say that all the rows and the first column's index is 0. Now y-axis is going to be y is equal to, let's show it in a better way, again matrix data, all the rows and the second column. Now we can go ahead and do the plot. We're going to say plt.plot x, y, and we can say plt.show. I'm going to comment out this part. Let's run our code once again. Okay, now we have our graph. If I maximize it, you can see that it's starting from 1700 and it's ending at 2020. And we have our average sunspot numbers year by year. You can see that in some years the average is real high, and in some periods the average is so low. This is related with solar cycles. Actually, the sun is having an activity period of approximately 13 years, which has a maximum in that 13 years and has a minimum. And some scientists are correlating this data with other scientific phenomena. This data has been taken from Royal Observatory of Belgium, and I'm going to be putting a link in the video description so that you can go and see for yourself. This will be the end of our video for today. In this video, we learned how to use Matplotlib and Numpy libraries in order to plot some data for creating multi-dimensional arrays by using the Numpy library. I hope the video has been useful for you. If you liked the video, please click on the like button and consider subscribing to the channel for further videos. Thank you for watching. Bye.